So now the followed by this Gaussian probability density function. Now we are going to discuss about Rayleigh density. So here this Rayleigh density why we are using is to find the envelope of two independent Gaussian processes. So this envelope can be found at the output of linear filter, so where the inputs are Gaussian random variable. So now this envelope how you can predict or how you can estimate using of linear filter. So now here this input for this particular linear filter is Gaussian random variables. So now these Rayleigh distributions are normally attributed to the envelope of multiple signal when there is no direct path. So previously we have discussed the noisy distribution we are evaluating using of Gaussian probability density function. But this Rayleigh density we are using for whenever that when envelope of multiple signals are there, but there are no direct path between transmitter and receiver. So this Rayleigh distribution, how you can define is P of x is equal to x divided by sigma square e power minus x square divided by 2 sigma square. So now the x value is greater than or equal to 0. So Rayleigh density, see here, P of x divided by sigma square e power minus x square divided by 2 sigma square. So now this is based on this Rayleigh distribution. Here also we need to evaluate the standard deviation formula. So now the standard deviation, see here that Rayleigh distribution. So in that curve, see that x value that starting of the point itself, we have the high peak value and slowly it gets decreases at that average. That means after that mid portion of the x itself, it gets to 0. So that is the curve for Rayleigh distribution. So previously that mid of the value we have the high peak value. So here that earlier itself we have the high peak value. So this is called Rayleigh density. So remember the Rayleigh density is nothing but it is there is no whenever there is no direct path for the multipath signal, then we can analyze this Rayleigh density. The next thing is uniform density. So this uniform distribution already we have learned in our basic classes also. So based on that distribution process only, here we are going to evaluate the signals from that various phases. That means here this uniform distribution to attributed to the distributions of random phase for propagating signal. So the signal has a random phase. We cannot predict the phase value. Sometime the signal may having 90 degrees, sometime it may having 120 degrees, sometime it may having 130 degrees, so like that. So each time you are while you are evaluating the signal has different phase value. So that for that here we are doing that uniform density distribution. So that uniform density distribution to evaluate the distribution of random phase for propagating signal. Not only does the phase delay tends to be uniformly distributed, but often the angle of arrival for diverse propagating waves can also take on uniform distribution. So here the three cases are involving. The first thing is random phase for propagating signal, and the second thing is phase delay, and the third thing is angle of arrival for diverse propagating waves. So the for that only that starting itself we have discussed, that means random phase of propagating signal. Random phase means that angles of arriving signal has different angle value we cannot predict. So for that the uniform distribution how you can define means, see here that probability of x is equal to 1 divided by b minus a and mu of x minus a minus u of x minus b. Here that u is nothing but that average. That means your mention is that uniform density. So for that only. So this mean value can be how we will take means that mean value means that u value. So a plus b divided by 2. So here for this probability density function, so how we can plot the uniform density function? Previously we have discussed the two types, the probability density function that is specifically for the noise and the changes in the amplitude value, but this uniform density for the random phase values. So now this curve for this uniform density is, see here. So here the a values, the distribution from a to be like that only we need to plot. Thank you.